Hi, Grandma here. This little video is to show you quickly how to operate Grandma's Game of Life, which is based on Conway's Game of Life, which is a very, very famous game that computer scientists and mathematicians have been totally fascinated with since the early 1970s. Okay, this is the board in Minecraft for Game of Life. Notice it's a rectangle of square cells. They're called cells. Blue means on, white means off. The outer border is gray, and it's there just to make everything look pretty. The border inside that, which is now red, means that the game is stopped. So if you look here, notice that it's stopped. When it's stopped, we can start a new game, which is what we want to do. And then the next border, which is purple, that border changes with each cycle. It goes from purple to cyan with each new generation, so that you can kind of tell where one generation starts and another one stops. So now let's run Blinker. Blinker is one of the simplest patterns. It's interesting because it repeats. Okay, there is Blinker. So once the pattern is entered, notice that the state is ready to go. Okay, that means you're going to go. And now notice that the border inside the gray border has turned green, bright green. That means it's running. Notice that the purple, cyan oscillates with each generation. Now we can pause it. That means it's paused, and notice now it says the state is ready to go. We could do go again, or we could make it go just one cycle. So let's do one. Now it's going to go from one generation to the next. And I use this to if I want to simulate in my head how the game goes from one generation to the next, using one is the way to go. Okay, we're going to watch it go a little bit more, and then we're going to stop it. Stop by the player. Okay, now there are 24 patterns built into Grandma's Game of Life, and you can go through them individually, and they are listed in the blog, or you can, we can select them by name, which is what I just showed you, Blinker. You can also select them by number. Pattern 7, I wonder what that is. Pattern 7. Okay, that is Beacon. Beacon's kind of a fun pattern. Okay, now we're ready to go, so we can go. And now Beacon is running. What is Beacon's cycles? How many generations does Beacon go before it repeats? It doesn't move, but it does repeat. Okay, let's stop it. And let's do Glider. Glider is one of the many patterns that move. And you can explore the spaceships. They are bigger than Glider, or Glider is really the smallest spaceship. And all the spaceships move around on the board. So it repeats, but it moves as it repeats. So there's old Glider. Okay, let's stop it. And now another kind of pattern is a random pattern. Let's do random with 10% of the cells on. There is a random pattern coming here. Yep, random. What's going to happen here? Do any of these cells have neighbors? They're pretty scattered out. I see one cell with a neighbor, or actually two cells with a neighbor, because neighbor is always reciprocal. Oh, never mind. Okay, let's go. Most of these cells will die. In fact, they all die in just one generation. Well, Let's make it more, how about 100% of the cells on? Let's do that. Okay, now they're going to all be on. You might wonder why they're being filled in sort of randomly, but when you look at the code, you'll be able to figure out why. Now, what's going to happen? Every cell has 8 neighbors. Now, the rules are if you have more than 3 neighbors, you die. So my guess is that everything will die in this generation, in the next generation. Here it goes. They're dying, dying, dying. White means they're dead. Dead, dead, dead. There it is. Got dead. One cycle. Well, let's do something in between. So let's do, well, let's run the default. Random. It's going to do 25 cells. So now some of them have neighbors, so let's go see what happens. And what is fun is to generate random patterns and then let it go until it either stabilizes or dies. Everybody dies. Stabilizes means that it might kind of accidentally reach some repeating pattern or an actual stable pattern, excuse me. Okay, what is going to happen? What is going to happen? Many of the patterns that are very well known now were actually discovered by generating a large field of random patterns and letting them run until something interesting was found. Okay. Looks like this one may run longer than we want to wait. So let's stop it. Now there's one other type of pattern. Now, notice when the inner ring is red, that means it's stopped. Okay. There's one more pattern that's kind of interesting. So let's, for example, let's generate a new board. Now I got a new board. Now let's say edit. So in edit mode, you can enter your own pattern by breaking blocks. So 1, 2. That's kind of interesting, don't you think? And I'm going to go up here and enter this. Well, that's a blinker, but it's right on the edge. Isn't that interesting? Okay, now that you've entered a pattern, you have to give it the command enter to have it actually enter the pattern. Now, it's orange, which tells you it's entering the pattern. And this is kind of a slow process because MakeCode has to test each block to see if it's blue. And that takes a while. Okay, the board has been entered. Now we can go. Okay, we got a blinker. Now here is something interesting. Notice that it's wrapping around. That is the cell on the bottom that's blinking every other time. It is the neighbor of the cells at the top. So this kind of board is called a wraparound board, and it's the most popular to implement. Some people implement one which is simpler, which means at the edge there are no neighbors at the edge, so that means things die a lot more often. Now, let's look over here and see what I haven't shown you. Pause, stop, enter, edit, random. You can resize the board, so let's just do that, size. And this number that you give it is the number of blocks in the side of a board. So now I set size, and I said new, and it generated a 20 by 20 board. So we could do random there, and I'll only do, well, let's not do that. And okay. Some patterns require a board that's bigger than the default of 10 by 10, and if it does, it automatically increases the size of the board, so you don't have to worry about that. Okay, we can run this one because I bet it doesn't take long for it to die because they're so. Although I see a couple of blinkers that are isolated. Did I say go? I said run, which is silly of me. See that blinker over on the right? That's isolated, but what if it gets something next to it? Yep, I think it's going to live. That's interesting. Over on the left, what do we have here? Is that a known pattern? Is it going to repeat? That's the real question. Will it repeat? Or will it stabilize? We got a blinker. We got a blinker. Nope, died. Okay. Okay, let's stop. Now, you know how to operate this. Have fun. Bye.